Hi guys, welcome back to Business Stats. This is the video for Module 3, Section 3.5, Multiplication Rule of Probability. Just go ahead and get into it. If you're following along with your companion worksheet, go ahead and write in the following definition, and that is just that the multiplication rule of probability is used to find the likelihood of two events A and B occurring together. Okay. Now, for independent events, we use the probability of A intersect B is equal to the probability of A times the probability of B. And for dependent events, meaning that they don't occur freely without each other, then the probability of A intersect B is equal to the probability of A times the probability of B given A, meaning the probability of B given that A has occurred. Okay, and that's there to show its dependency. Okay, so we will get into this. All right, so example 1. A nationwide survey showed that 65% of all children in the United States dislike eating vegetables. If two children are chosen at random, what is the probability that both of them dislike eating vegetables? Okay, so this might be obvious to most people, but so if two children are chosen at random, it's just going to be the probability of disliking eating vegetables, say dislike, times the probability of dislike. So these are just two separate kids. 0.65 times 0.65 is equal to 0.4225. So these would be independent events, right? Like these kids have nothing to do with each other, but they fall under the same distribution of 65% of them don't like vegetables. So the probability that they both don't like vegetables is 0.4225. And that's it. So that's the rule for independent events, right? Because each child doesn't depend on each other. Okay, so now we're going to see something that has to do with dependent events. Example 2. Sheila bakes cookies at a bakery. She bakes a batch of Sounds like I'm about to do a rhyme, I guess. She bakes a batch of a dozen cookies with peanut butter and chocolate chips, and one batch of a dozen cookies with just chocolate chips. Once baked, they are placed on a single tray for customers to select. What is the probability that a customer chooses two cookies with peanut butter and chocolate chips? All right. Okay. So she bakes a dozen of each, and there's two different kinds. So we can just say, we'll call the peanut butter and chocolate chip A, and we'll call the chocolate chips B. Okay? So what is the likelihood that somebody picks? So the question is, what is the probability that a customer chooses two cookies with with both peanut butter and chocolate chips? So two A cookies. Okay. Well, what's the probability of choosing an A cookie? So the probability of choosing an A cookie is what? It's just going to be the number of cookies over the number total. So it's going to be 12 cookies, so a dozen cookies out of the 24 that they have. And then the probability of the second thing would be, so the probability of choosing another one of those cookies is going to be, just going to be the given probability, which is just then the likelihood of getting it given that you already picked one. Well, so because you already picked one, it takes one away. So there's only 23 cookies left, and 11 of them are these A cookies. So it's going to be 11 over 23. And so then we multiply those together. So 12 over 24 times 11 over 23. And we ultimately get 0.239. Okay, so now you try. Then we will get back. So go ahead and pause the video, and we will get back to solving this. All right, guys, hopefully you had time to pause the video and solve this problem. 40% of adults live in Northeast Ohio. living in Northeast Ohio have been to a Cleveland Browns game. If 3 adults are chosen at random, what is the probability that all of them have been to a game, right? So these are independent events. They don't depend on anything else. So this is just going to essentially be the likelihood that each one of them has been to a Browns game times each other. So 0.4 times 0.4 times 0.4, and that equals 0.064. That's that. So that's the multiplication rule for independent events. So that's taking it for more than just 2 events, right? That's for 3 events, right? We have the event of one person doing it, the second person, and the third person all independently. So here's the second U try. So now this is going to be a little bit different. This is when we're going to be putting this into a dependent version, right? So the U try. So go ahead and pause it and give it a shot. Okay, hopefully you guys had a chance to work on that. So this one is a very similar problem, but we'll see how it differs. 40% of people in the classroom have been to a Browns game. Assume 30 people in the class. If 3 are chosen at random, what is the probability of that all of them have been to a game? Okay. Well, now, so 30% or so 40% of, first of all, we just need to find out what that actually means. So 40% of 30 people is how many people? It's 12 people. We'll just say 12 of our 30. And so now this dependent probability is going to look a lot like, well, the probability of the first person being chosen, 12 over 30. Well, so now given that that person is chosen, well, what's the likelihood that another person is chosen? Well, it's going to be the remaining people that have been to a Browns game divided by the remaining people in the class, 11 over 29. And then furthermore, we do that again. So the remaining people that have been chosen, or that have been to a Browns game, over the remaining people in the class. So we multiply all those together. It's 1320 over 24,360. It gives us 0.0542. There you go. Well, guys, if you have any questions on the multiplication rule for probability, go ahead and ask those in the discussion forums, or shoot me an email, or ask a classmate, or, I don't know, research it on YouTube, or look it up on Google. There's multiple sources. There's multiple ways to go about this, but definitely want to get you where you need to go. All right, guys, and stay tuned for the next video, which will be 3.6, using the complements, the rule of complements in probability. All right, thanks so much. See you next time.